Hello everyone. I hope I don't need introduction, and if at all you need, we shall see it some other time. I have come today to discuss few terms related to your first module, and I shall explain some of them. So like the terms Poisson's ratio, Hooke's law. So you may immediately might have in your mind it has been already discussed. Why again? Okay, I probably you have gone through the definition point of view, and now I shall explain what do they mean, how we can incorporate, take them in our analysis, etc. That I shall explain. Then knowing this Poisson's ratio and Hooke's law, then I shall expand this Hooke's law, what is called as make it generalized Hooke's law. And in while understanding all this, we shall also go through something unknowingly, and that is what is called as principle of superposition. All that we shall try to understand. Okay, so let us start with the first term, what is called as Poisson's ratio. Poisson's ratio, as you all know, okay, you know what is meant by strain. So we have what is called as strain in the longitudinal direction. Say imagine a circular bar, you are pulling it. When you pull it, you know that its length is going to increase, therefore there is a strain in the direction of the load. So when its length increases, what happens to its diameter? Its diameter is going to decrease. That means there is strain in that direction also. Okay, so that's what. Then this strain, the strain in the direction of the load and the strain perpendicular to that, they are related. And that is what we have a relationship, what is called as lateral strain divided by longitudinal strain for any given material. Please remember, for any given material it is a constant. Okay, it is a property again. Property. What do you mean by property? As you all know that. So house is a property of somebody. Okay, like that. This Poisson's ratio, every material has its own value. So therefore, we say that this is a property. Poisson's ratio is a property. Say for aluminum is so much, for steel it is so much, for copper it is so much. Like that, it is a unique value. That is why we say that it is property. Okay, then why we have something, the two lines here. I hope you understand what is the meaning of this line. These lines we call it as modulus. What do you mean by modulus? Modulus makes any value that it makes it positive. So please understand here longitudinal strain and lateral strain. Again, let me come back to the bar problem. So you have a bar, you pull it, and its length is going to increase. Its length has increased, therefore the strain, what I call it as a positive strain. When the length increased, I have a positive strain, and in the lateral direction the diameter has decreased, and therefore there is a negative strain. So remember, longitudinal strain and lateral strain, they are always opposite. If longitudinal strain is positive, lateral strain is negative. Vice versa. If the longitudinal strain is negative, you are applying compressive force, its length is decreasing, the longitudinal strain is negative, in that case the diameter is increasing, diameter is increasing, and therefore the strain in that direction is positive. So one of them is always negative, and therefore this value is always a constant. And I don't want a property of a material to be a negative value, so I don't want it, and that's why we say that we want to make it positive. How to make it? The best way is to take the modulus of that. So there is another way of defining. If you don't want modulus, then we always start with what is called as, we put a minus sign at the beginning only. Minus of this ratio is what is called as Poisson's ratio. You may have this minus sign, or you may have what is called as the modulus of. So how do we define Poisson's ratio? Poisson's ratio is the modulus of the ratio of lateral strain to the longitudinal strain of a material within elastic limit. Please remember, within elastic limit, though we don't mention it, it is understood. So the moment you exceed the elastic limit, then your strains are no more elastic strains, or they are not going to vanish once you remove the load. The strains are going to remove. Therefore, Poisson's ratio, when you say this along with all that, don't forget to say within elastic limit, that must be set. Okay, all that, lateral strain and longitudinal. So we may have a confusion, what do you mean by lateral, what do you mean by longitudinal? So for that, okay, to explain, say I have taken, what do you call it, you can call it as a rectangular prism. So which is having dimensions, say x dimension and y dimension and z dimension. So why I have chosen x, y, z? Just to, I assume that x axis, y axis, z axis, I refer it. Please remember these axes can be changed and accordingly these dimensions also you can have different. Okay, so x, capital X is some value. Please remember this length is this x and this length is y, the height is y, and the depth perpendicular to the board is what is called as z. So I have three dimensions, x, y, z. Okay, there are some values, and as for the diagram, it appears that the x value is much more compared to y and z. Doesn't matter, no problem. Okay, so now what is the longitudinal direction here? What is the longitudinal direction? What is the lateral direction? Okay, so normally looking if the length is more, then we have an axis and we normally tend to answer that. So this axis or this length is what is called as the longitudinal axis. Okay, longitudinal axis is alright, but it is nothing to do with what is called as longitudinal strain or lateral strain. Okay, so as it is, I am unable to say what is longitudinal direction, because once I apply load, then only I shall know what is the longitudinal direction. Strain in the direction of the stress or strain in the direction of the load is what is called as longitudinal strain. And any strain perpendicular to that, that is what is called as lateral strain. Okay, I hope you understand. Okay, this is x, y, z. And these are the dimensions before I apply load. The cross section is rectangular, assuming that y and z are different. And in a special case, if y is equal to z, then it will be a square. The cross section is going to be square. So if I take perpendicular to the longitudinal axis, perpendicular to the board, if I take a plane and cut it, and always the area is going to be y into z. Okay, such a beam, such a member, such a bar. So I want to apply a load. Okay, I want to apply a load, and the load I call it as, say, F suffix x. Similarly, I apply on this side also. I am applying a load what is called as F suffix x. Only one load along with the axis, along x axis I have applied. And if I extend it, and it is going to coincide this, and this load, they are along the axis. Okay, I have applied only a load fx. Okay, then immediately I don't want to deal with load, I want to convert, I want to deal with what is called as stress. Okay, so I want to deal with what is called as normal stress, and immediately I calculate what is the stress along the x-axis. Sigma x is equal to fx divided by what is the area perpendicular to the load. What is the area perpendicular to the load? This is the load, and what is the area perpendicular to the load? That is nothing but this area. And what is this? This value is z, this value is y, this is rectangle in cross section, and this is equal to yz. And this is what I call it as sigma x. So immediately what I do is, I don't want to deal with the fx. Even if fx is given in the numerical problem, you know how to convert that into sigma x. I hope now I convert it into what is called as, I don't have fx, I call it as sigma x. Sigma x is the stress what I have applied, but you can't really apply sigma x, you actually apply fx, and fx divided by the corresponding area, that will give you what is called as sigma x. Okay, so sigma x. So now any strain you calculate due to sigma x in the direction, this axis is what is called as the strain in this direction along this axis is what is called as longitude. And any strain in the direction y-axis is what is called as, it becomes lateral. And any strain perpendicular to the board, that is nothing but z axis, that is what is called as lattice. So that means this sigma x, though I have applied load only along x axis, I have strain along x axis, I have strain along y axis, and I have strain along z axis. Okay, if I call it as epsilon x, the strain along x axis, strain along y axis, epsilon y, strain along z axis, epsilon z. Okay, so now, so strain due to sigma x along x axis is longitudinal, and therefore according to Hooke's law, what is Hooke's law? Within elastic limit, stress divided by strain is a constant, and that constant is known as Young's modulus of elasticity. Okay, so sigma divided by epsilon is equal to E, or in other words, epsilon is equal to sigma divided by E. So therefore, epsilon x, applying Hooke's law, this is longitudinal strain due to sigma x, therefore this is equal to sigma x divided by E. Okay, so now what is the longitudinal strain is sigma x by E, and Poisson's ratio, I shall use the notation, and this notation is read as nu. So nu is the notation I am using, and in some books they use what is called as mu. And civil engineering books, if you refer, then it is being referred as 1 upon m. These are the different notations for Poisson's ratio. We shall continue to use this. Say something like this, a horizontal line, and something like u, and then point. So this is how we normally represent it. That is Poisson's ratio. Okay, so then I want to calculate now what is the strain in y direction. Strain in y direction is a lateral strain. Okay, again go back. Lateral strain is equal to nu times longitudinal strain. Okay, so first, before you decide or write down, is it positive or negative? If this is positive, then this will be negative. This also will be negative. So therefore, this is minus. This also is minus. Minus how much? It is nu times sigma x divided by E. Minus nu times sigma x divided by E. This is what? Okay, these are the strains in x direction, y direction, and z direction. Okay, what may be epsilon x? What do you mean by epsilon x? The strain in the x direction. What do you mean by strain in the x direction? The change in the dimension in the x direction divided by the original length. That is nothing but delta x. This is the change in the dimension divided by what is called as the original dimension. This. Similarly, epsilon y is equal to delta y divided by y, and similarly epsilon z is equal to delta z divided by z. So you know epsilon x, epsilon y, assuming that you know sigma x and E. Knowing sigma x and E, you know epsilon x, and knowing the Poisson's ratio of a material, say from which material this bar has been made, then you know the material and you can refer to the data handbook, and it is a property of the material, and therefore immediately you will come to know what is the Poisson's ratio. So therefore you know this also, and you know this also. So therefore this delta x divided, epsilon x is known, epsilon y is known, epsilon z is known, x, y, z are known. Therefore from this what you can find out? You can find out what is delta x, you can find out what is delta y, and you can also find out delta z. What is delta x? The change in the value of x in the dimension x. Please remember, delta x is nothing but x final dimension minus the initial dimension. Initial dimension is x. So you know delta x, you know capital X, or in other words, xf is equal to x plus delta x. And similarly, yf is equal to y plus delta y. And similarly, ZF, the final dimension, is equal to Z plus delta Z. Okay, so now delta Y, as it appears, this is going to be negative. So I forgot to put it here. Okay, this no problem. Epsilon Y is already negative. This is negative. This delta Y is going to be negative. Delta Z is going to be negative. It doesn't matter. So you have to take along with the sign here and find out what are the dimensions of in the x direction, y direction, z direction. You can easily find out. And what will be the final volume? So if I want to know what is the change in the volume, okay, what is the change in the volume of this? Please remember, normal stress, whatever you apply, they will change the dimensions, but they will not change the shape of the body. The shape, what do I mean? The cross section of this is rectangular before the application of these loads. Once I apply loads, the cross section dimensions will change again, it will remain rectangle only. Please remember, it will not become circle or anything triangle. So that's why the shape of the body will remain same. The normal stresses, they are not going to change the shape of the body. But the shear stress, which I am going to introduce shortly or maybe in the next class, that will change the shape of the body. That will distort the shape of the body. That is why shear stress is also called as distortion stress. It will distort the shape of the body. But here I don't have that. Okay, now I want to find out what is called as one more thing. What is called as volumetric strain. So I shall define something. What is epsilon is the symbol for strain. I put what is suffix V. Suffix V. What is that? Volumetric strain. What is the volumetric strain? The change in the volume. So any strain, change in dimension. So volumetric strain, change in volume. That I can call it as delta V. Delta V divided by the original volume V. So how you can easily find out? You can easily find out what is delta V? The final volume minus initial volume. What is the final volume? Because since it is a rectangular one, you can find out what is XF, you can find out YF and ZF. Find out this. Multiply all this. This will give you the final volume. Minus what is the initial volume? X, Y, Z. The whole thing divided by the initial volume. What is called as X, Y, Z. So this is how I can find out what is the volumetric strain of the body. Okay, remember I have taken only the stress in only one direction, sigma x here. Okay, now I am going to expand it. Expand it. What do I mean by? If we have stresses in only one direction, then that kind of problem is called as one-dimensional problem. And if you don't have stress in only one direction, you have stresses in two directions, say along x-axis and also along y-axis, then it becomes two-dimensional. Then I don't have only two-dimensional, I have load in all possible directions. In general, it is a three dimensions. X direction, Y direction and also Z direction. That's what I mean by generalized. Okay, general loading in general, the load is in all the directions, not only along X, not only along Y and all Z. Okay, so therefore that is what I would like to expand it. Okay, now let me take, I don't have only sigma X, what else I have? I also have sigma Y and sigma Z. Okay, so I don't have sigma Y, actually I have Fy, the load. The load in the Y direction. What is the Y direction? This perpendicular direction. This is what? Say I have a load here. So this is Fy and bottom surface. This one I have a load. What is called as Fy. They are the same thing. Okay, so what is Fy? But I don't want sigma Y. How do you calculate the load in the stress in the Y direction? That is nothing but Fy divided by the area. What is this area? That is this entire area. So that is nothing but this dimension and this dimension. That is Fy divided by xz. If you do it, you will get sigma y. So therefore I shall replace this Fy by what is called as sigma y. Sigma y. Okay, now I shall replace it. I shall explain. I want to make it generalized. I don't want in only this thing. I have one more. Z direction. What is Z direction? Perpendicular to the board. And one load I have like this. Perpendicular to the board. Acting on this face. Please remember. And another load exactly away from, in the perpendicular direction only and away from us. And that will be acting on this. Let me take that load. That is acting on this face. And that load, I call it as Fz, and perpendicular to that, exactly behind it, I have one more load. That is Fz. Then I shall calculate what is called as sigma z, strain, no, not strain, stress, normal stress in z direction. Sigma z is equal to Fz and the area perpendicular to the load. The load is like this, please remember, the load is like this. What is the area? That is nothing but this area. What is this area? What is this area? This dimension is x, this dimension is y, therefore divided by x into y. If you do it, you will get Fz, the sigma z, and I shall replace it and get what is called as sigma z, sigma z. Now I would like to calculate what is called as, what are the dimensions. Okay, before the application of these loads, the dimensions were x, y, z. Now I have applied load in all possible directions, all the three directions. What are the loads? Sigma x, sigma y and sigma z. And the material from which it has been made is having an Young's modulus of elasticity E. And similarly, the material has Poisson's ratio which is equal to nu. That's all I know. I know sigma x, sigma y, sigma z. I know nu, I know E, and I have been asked to find out what is the volumetric strain. And maybe one step before, what are the dimensions along x-axis, what are the dimensions along y-axis, what are the dimensions along z-axis after the application of these loads. Okay, so now please remember here, it is quite complicated. Complicated in the sense, I have strain along the x-axis not only because of sigma x, I also have strain in the x-axis because of sigma y and also because of sigma z. The strain due to sigma x along x-axis is longitudinal. The strain due to sigma y along x-axis is lateral. The strain along x-axis due to sigma z is again lateral. So this is true. So in the y direction, if I want to calculate, the strain due to sigma y is longitudinal. The strain due to sigma x and sigma z, they are lateral. And similarly, you can extend this argument for the strain in the z direction also. So now this is where I bring into what is called as principle of superposition. Okay, what does it say? Okay, a body is subjected to a number of forces. A body is subjected to a number of forces. I want to study what is the effect of all due to all those forces. Okay, this process becomes complicated. What I do is, I take only one force at a time. Find out what is the effect of due to one force on the body. Then take the second force, only one force. Then find out what is the effect. Like that I do all due to all the forces. Then I add the effect due to all individual forces to get what is called as the effect due to all the forces. This is what is called as, both of them are one and the same, and that is what is called as principle of superposition. Okay, probably we can try to put it in words. Principle of superposition states that, what is that? The effect due to what? the effect due to a number of forces. The effect due to a number of forces on what? On a body. The effect due to a number of forces on a body is the sum, S-U-M, the sum of the effect due to individual force, the sum of effect of individual force on the body. Quite simple. The effect of a number of forces on a body is the sum of the effects due to an individual force on the body. This is what is meant by superposition principle. Okay, what do I mean by, how do I apply? So what I do is, I find out the strains in all the three directions due to sigma x only. Sigma x along x axis, sigma x along strain along y axis due to sigma x along z axis. Similarly, I take only sigma y, I sigma y, and then I take only z, sigma z, and then I find out what are the strains in all the three directions. I add them, and that's what is called as principal superposition. Okay, so now say I make it three parts. So what I want? I want the strain in x direction, strain in y direction, and strain in z direction. This is what I call it as, say, one row, and then the second row, and third. And then I add, okay, and then to get what is the total. Okay, now due to sigma x, I find out what are the strains in x direction, y direction, z direction. Okay, due to only sigma x, I forget, as if I don't have sigma y and sigma z, I find out. Okay, please remember sigma x, what is x direction? Is it longitudinal or is it lateral? Sigma x, x axis, sigma x, and this direction, this is longitudinal. So longitudinal, definitely I shall write it as sigma x by e. And due to sigma x along y axis, due to sigma x along y axis, it is lateral. Therefore, it is minus mu into sigma x divided by e. Similarly, due to sigma x in z direction, again it is lateral. This also is minus mu into sigma x by e. So these are the strains due to only sigma x in x direction, y direction, and z direction. Okay, please remember, this is only strains due to sigma x. I have not considered sigma y at all. Now what I do is, I shall take only sigma y. I shall take only sigma y, as if sigma x and sigma z are not there. Okay, for sigma y, which is the longitudinal direction, that I shall write first. Y direction is the longitudinal direction. Therefore, this y direction, I shall write it sigma y divided by e. This is the longitudinal strain. What will be the lateral strain? If this is positive, then this also will be negative, this also will be negative. How much? This is minus mu into sigma y by e, minus mu into sigma y divided by e. And the same thing I can easily extend it, what is called as due to sigma z on the same lines, or sigma z perpendicular to the board, that direction is longitudinal. Therefore, this is sigma z divided by e. And this is minus mu into sigma z by e, minus mu into sigma z by e. Please remember, these are the strains only due to sigma x. These are the strains in different direction only due to sigma y. These are the strains due to sigma z only. But the actual body is not subjected to only sigma x or only sigma y or only sigma z. We have actually all the three, sigma x and sigma y and sigma z. So now what are these? These are the effects in the three directions due to only this. these are the effects in the three directions, only this. These are the effects due to sigma z, okay, in three different directions. But due to all this, what is that? The effect due to all these three simultaneously is the sum of the effects, sum of the individual effects. So if I want to know the total effect due to sigma x, sigma y, sigma z, what I should do? I have to add this. If I do that, this is the strain due to sigma x, this is the strain due to y sigma y, this is the strain due to sigma z in the x direction. What is this? This is nothing but epsilon x. Similarly, so to get the strain, this is plus, this plus. And what is this? This is the epsilon y. This is equal to, on the same lines, and this is equal to epsilon z. Now what we have done is, we have applied principle of superposition and then found out what is called as epsilon x, epsilon y, epsilon z. And the earlier discussion, what is epsilon x? What is epsilon x? This whole thing, this is nothing but delta x divided by x. The whole thing, this is equal to delta y divided by y. This is equal to delta z divided by z. Okay, so knowing all the sigma x, sigma y, sigma z, e and nu, you can easily find out this. And once you find out that, you can easily find out delta x, delta y and delta z. And if you find out delta x, delta y, delta z, you can find out what is the final x, that is xf. Then you can easily find out what is yf, find out what is called as zf. That is nothing but x plus delta x. This is nothing but y plus delta y. This is nothing but z plus delta z. Please remember these delta x, delta y, delta z, they are very, very small, and whenever you are asked to calculate volumetric strain, so I wish you to take these values delta x, delta y, delta z to at least 4 decimal places. Take those values up to 4 decimal places. Otherwise, if you take only 1 decimal place, then your round off error is too high, and therefore you won't be able to get the expected value of the volumetric strain. Okay, so once you know xf, yf, zf, the product of all these three will give you the final volume, and x, y, z will give you the product will give you the initial volume. The difference between the two will give you the change in volume. The change in volume divided by initial volume, that will give you what is called as volumetric strain. Okay, I hope you have understood this. If you have any doubt, I have made it very general, and I shall give you maybe in the next class a problem, okay, involving all that, and probably in the next class I shall introduce you what is called as the shear stress, then what is meant by modulus of rigidity, then bulk modulus, and relate all these things. Okay, so all these things happen to be property of a material. If one's property, how they are related, that all that explained in the next class. Thank you, good day.